very warm welcome to WsCube Tech. So guys, in our previous session we have covered that what is the difference between NumPy arrays and matrices. In our today's session we will be talking about functions related to the matrices. So in our matrices, as we have studied in our grade 12, that in our matrices there are many functions. For example, that finding a transpose of a matrix, finding an inverse of a matrix, the determinant of the matrix, adjoint of the matrix. All these methods over here are very simple to find. So let's have a look on how they can be found in our NumPy matrices. So guys, here we will be writing import NumPy as NP. Once we have imported NumPy as NP, first of all, the first thing that we are going to do is create an array or create a matrix over here. Because we are working on a matrices function, we will be creating a matrix over here. So I'll be writing mat is equals to NP dot matrix, and we'll be creating a matrix over here by passing parentheses. Inside the parentheses, I'm creating a two-dimensional matrix. So 2, 3, 4, 6. Once I have created this, the first thing that we need to do over here is finding the transpose of a matrix. For transpose of a matrix, let me just add one more matrix over here. So I'll put a comma and create another pair over here. So another row I'm adding basically. That is, let's say 5, 7. Okay, so now what is the transpose of a matrix? Let's understand that. So suppose if you have a matrix called as 1, 2, 3, 4, 5, 6. Suppose if you have a matrix which looks like this, which has 3 rows, that means 1, 2, 3 and 1 and 2 columns. So we have 3 rows and 2 columns here. Now what do we need to do to find the transpose? The transpose of a matrix over here is, so now what do we need to do? We need to find the transpose of a matrix. So transpose of a matrix would be 1, 2, 3, 4, 5 and 6. In this way you can find the transpose of a matrix. That means the rows will be converted into the number of columns and the columns will be converted into the number of rows. That means the rows were 1, 2 and 3. Sorry, the columns were 1, 2 and 3. Now they will become a row. That means it will go in this way. We will be having 1, 2, 3 in this way. And 4, 5, 6 was the other column. So the 4, 5, 6 will become the next row over here. This is how you can find the transpose of a matrix. Now if we apply the same method in our PyCharm, so it would look like this. Let's first print matrix. So I'll just print mat. And as soon as we run it here, we'll be getting the output 2, 3, 4, 6, 5, 7. That means 3 rows and 2 columns. And to find the transpose of it, what we'll be doing, I'll be writing print transpose. The first one is using transpose function. And here I'll be writing print. So I'll be writing over here np dot transpose. And inside this I'll pass matrix, that is mat. And if I run it, I'll be getting the output in this way. So now you can see over here that if we use the transpose function, after using transpose function 2, 4, 5, that means 2, 4, 5 was the column over here. This has been converted into a row. 3, 6, 7 was the column over here. It has been converted into a row. This is how you can find the transpose. Another method over here is writing print and mat dot capital T here. So let's run and see. So this will be using the T function, or we can call it a T method. So I'll be just writing print using T method, capital T method. Let me put it inside the double quotations here. So now if we run it, let's see what output we will get here. So by T method also we are getting the same output. That means whatever output we are getting from our transpose method, the same output we are getting using the T method. Also we have another method over here that is called as print mat dot transpose. As soon as we run it, we'll be getting the same output, that this is using the transpose function again, but this time we don't have to use the numpy dot transpose, but we can directly write the name of the matrix and dot transpose and call it over here. So this is how you can find the transpose of a matrix. Let me just put this inside the comment. Next thing that we are going to do over here is find the diagonal elements. For example, if we have a matrix called as mat is equals to np dot matrix, and here I'll be passing some elements. So I'll be writing 1, 2, 3, another matrix, let's say 4, 5, 6, and let's say another matrix that is 7, 8, 9. And I'll be putting them inside another matrix over here. And once I have another matrix, let me just print this first. So I'll just show it to you by printing it, that what kind of matrix we are obtaining over here. So if we run it, we got a 3 by 3 matrix over here. Now if I want to find the addition of the diagonal elements, to find the addition of the diagonal elements, we have a very simple method that is called as print mat dot trace, and trace over here means, just understand that with the help of an example. So I'll be writing, for example, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9. The sum of the diagonal elements would be 9 plus 1 plus 5, that is 15. Let's see if our trace method is giving us the same output or not. So as soon as we run it, we'll be getting the output as 15. That means our trace method over here is working properly. Similarly, if you want to just obtain the diagonal elements, to obtain the diagonal elements, all we need to do is write print mat dot diagonal, and as soon as we run it, so we will be obtaining the diagonal elements, that is 1, 5 and 9. So 1, 5 and 9 are our diagonal elements. So this is how our trace and diagonal elements work. Let's move ahead and talk about the determinant of a matrix. So first of all, let's understand what is determinant of a matrix. So I'll just move this up, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. To find the determinant of the matrix, what we do, we write 1 comes exactly like this, and we have 5, 9, 6, 8. We need to find the cross multiplication of 5, 9, 6, 8, and that would be 5, 8, 6, 9, and we'll be finding the cross multiplication minus we will write the second element over here. Second element is 2. And here in the matrix we have, so we will be ignoring this and this. So we will be getting 4, 9, 6, 7. So 4, 9, 6, 7 plus 3, next element. So we will be putting 3, and this time we will ignore this first row and this last column here, and we will be having 4, 8, 5, 7. So 4, 8, 5, 7. And then after calculating the output, whatever output is there, that is the determinant of the matrix. Now this is the long procedure, right? And in our NumPy, in our matrices functions, we have a very simple method by which we can, to find the determinant over here, all we need to do is write print np dot linalg dot, because we are going to find the determinant, so we will be writing det. Whose determinant we need to find? We need to find the determinant of the matrix over here, so we will be writing np dot linalg dot determinant of the matrix. So now if I run it, I will be getting the output over here as 0.0. So the determinant of this matrix is 0.0, but let me just change this value to something else. Let me just put over here 12, and now if I run it, the output would be, let's say, minus 83.9999. Okay. Similarly, you can also find the rank of a matrix. To find the rank of the matrix, we have a simple method by writing print np dot linalg dot matrix rank, and whose rank we need to find, this matrix rank we need to find. So as soon as we run it, we'll get the output 3 over here, that is so it has a rank of 3 over here. Next function that we have over here is to find the inverse of a matrix. Let's understand what is the method of finding the inverse of a matrix. So suppose if you have a matrix, so let's say you have a matrix A. The inverse of the matrix would be A and raised to the power minus 1. Now, how to find the inverse of a matrix? For that, we have a formula, that is 1 divided by determinant of this matrix multiplied by adjoint of this same matrix. So this is the method over here. Then you have, what you need to do, you need to write 1, 1, then you need to find the whole determinant of any matrix, and then after that you have to multiply with the adjoint of that similar matrix. So that's a very long procedure over here, so I'm not going to solve it basically, because that is not of use. What we need to do, we can just put a simple function in our NumPy matrices, that is, so I can write over here print np dot linalg dot inverse. Whose inverse we need to find? The matrices in a inverse we need to find. As soon as we run it, we will be getting the output as this. So this would be the inverse of this matrix, while at the same time, suppose if any matrix has a determinant of 0. Suppose the determinant of 1, 2, 3, 4, 5, 6 and 7, 8, 9 was coming 0, right? And if I try to find its inverse, it would throw me an error over here. It says it is a singular matrix. You cannot find a inverse of a singular matrix. That means if any of the matrix gives you a determinant as 0, then you cannot find the inverse of that matrix, because what is the formula over here is, the formula over here says that 1 multiplied by determinant of A. So over here you will notice that what our formula says, our formula says that A divided by determinant of A. So now if A divided by 0 will come, then it will obviously throw us an error. So that's why what we do, if there is a, so that's why what we do, if the determinant of any value, any matrix is 0, in that case we cannot find its inverse. But in NumPy there is a method for that as well. For that, all we need to do is, you can just write print nb dot linalg dot pinv of matrix. So this is a method by which you can find the inverse of a matrix whose determinant is 0. So if I run it, I will be getting the output now as minus 6 point something, minus 1.6, minus 3.05, minus 5.5, minus, it's plus, so 1.30, 5.5 again, 5.27, 1.66 and minus 1.94. So in this way, we can find the inverse of a matrix whose determinant is 0. So I hope guys that all the methods over here are clear to you. We have covered almost all the functions related to the matrices. Our first function was to find the transpose. To find the transpose, there are 3 methods. We can use the transpose function or use the T method, or we can also use the mad transpose function. Next, we talked about the trace or the diagonal elements, that if you want to obtain the diagonal elements, you can write mat.diagonal and you can obtain the diagonal element, while at the same time if you want to find their sum, in that case you can write mat.trace. Then we found out the determinant of a matrix by writing np.lineal.determinant, and we can pass the matrix over here inside the parentheses. After that, we have found the rank of the matrix by writing np.lineal.matrix underscore rank of the matrix, and here we have found the inverse of the matrix where the determinant is 0 and not 0 as well. So I hope guys that you have no doubts in the question in the functions of the matrices. From our next session, we will be starting a completely new topic. That means we are starting with a completely new library that is called as pandas. So stay connected guys, and I'll see you in the next session. Thank you.